Okay, let's dive right in. You know, all around us, every single day, there are these tiny, invisible chemical dramas playing out. And believe it or not, we're going to solve a few of them today, using the science of acids, bases, and salts.
I mean, we've all been there, right? You have a big meal, maybe a little too much pizza, and then that uncomfortable burn. What is actually happening inside you when you feel that?
And it's not just indigestion. Ever wondered why a bee sting hurts so much? Or, and this one's kind of weird, have you ever noticed a yellow curry stain on a white shirt turn this reddish-brown color when you scrub it with soap? These aren't just random things happening. They're clues.
The answer to all of these little mysteries, it's the same thing every time. It's this invisible battle, a chemical tug-of-war, happening between two very different, but super common, types of substances.
All right, so let's meet the main players in this chemical drama. We've got acids and bases. They have totally distinct personalities, and there are some really simple ways to tell them apart.
Okay, the classic test is taste. You know, acids are sour, like a lemon, and bases are bitter. But please do not go around tasting chemicals. Instead, scientists use something called litmus paper, and it's got a simple rule. Acids turn blue litmus paper red, and bases, they do the exact opposite, turning red litmus blue.
And that brings us right back to that crazy curry stain. It turns out turmeric is a natural indicator, just like litmus paper. So when the soap, which is basic, hits the stain, the turmeric literally changes color to that reddish brown. Mystery solved. How cool is that?
So, what happens when these two opposites finally meet? Well, that's when we get to the main event. This is the chemical reaction that explains pretty much everything, from why antacids work to how you treat a bee sting.
It's a process called neutralization, and the formula for it is just so simple and elegant. When you mix an acid and a base, they essentially cancel each other out. And what do you get? A salt and plain old water. Okay, let's circle back to that indigestion problem. That burning feeling? That's just too much hydrochloric acid in your stomach. So what do? You reach for an antacid, something like milk of magnesia, which is just a mild base. That base gets in there and neutralizes the excess acid, and boom, you feel better.
Acids can have some other really dramatic reactions too. I mean, there's this classic lab experiment where you drop a piece of zinc metal into acid and it just starts fizzing like crazy, releasing hydrogen gas. And the test for that gas, it's the best part. You bring a lit match or a candle near the bubbles and you get this awesome little pop sound as the hydrogen ignites. So cool. But here's the thing. Not all acids and bases are created equal. Some are incredibly strong while others are super mild. So how do chemists actually measure their power level? They use something called the pH scale. The easiest way to think about it is like a power meter for acids and bases. It runs from 0 for a really, really strong acid all the way up to 14 for a very strong base, which you might also hear called alkaline. And right there in the middle, at a perfect 7, is neutral. Think pure water. And look, this isn't just some abstract number for a chemistry textbook. pH is absolutely critical for life. I mean, our own bodies have to stay in this super narrow pH window just to function. You've heard of acid rain, right? That's just rain with a low pH, and it can totally devastate rivers and lakes. Even tooth decay. That whole process kicks off when acids from bacteria drop the pH in your mouth below 5.5. To really get a feel for these numbers, just look at some everyday examples. You can see the extremes here, right? Your stomach acid is way down there around 1.2. And the antacid that neutralizes it, milk of magnesia, it's way up at 10. And smack in the middle, you've got lemon juice around 2.2 and pure water at that perfect neutral 7.0. Okay, so we've established that an acid and a base neutralize each other. But what's actually left behind after the battle is over? The answer is honestly way more interesting than you might think. Right, we saw the formula. Acid plus base gives you salt plus water. We all know what water is, but what exactly is that salt? And let me tell you, it is not just the stuff you put on your French fries. That's just one type of salt, sodium chloride. In the world of chemistry, salt refers to this massive family of compounds, and so many of them are completely essential to our daily lives.
You'd honestly be shocked by what's considered a salt. Baking soda, the stuff that makes your cakes fluffy and can soothe an upset stomach, that's a salt. Washing soda, used for cleaning and making glass, also a salt. Bleaching powder, plaster of Paris that doctors use to set broken bones, yep, all different kinds of salts. They're all the product of their own unique acid-base reaction. They're kind of the unexpected heroes of this whole chemical story.
So, this invisible battle, this dance between acids and bases, it truly defines our world, from what happens inside our own bodies to what happens in our bakeries. Which leaves us with one final kind of mind-bending thought. This chemistry is fundamental to life here on Earth, but what about other worlds? I mean, the atmosphere of Venus is choked with these thick white clouds of pure sulfuric acid. It really makes you wonder, doesn't it?